Kirchhoff's loop law. Okay. First rule says that for current and the voltage, for both the things, okay, if this is a point of joining of all the wires, so many wires are coming here, some charges are going, just like your this better example in the extension cords.
Yeah.
One current is coming, and from that outlet so many outcomes are there. One is connected with your TV, one is connected to your speaker, one is connected to your lights, one is connected to your, suppose this is your incoming current. Okay, incoming current. Then one is connected with your Geo, okay, Geo fiber set-top box. One is
Yeah.
connected to some. Tell me the example. लाइट्स हो गए, स्पीकर हो गया, टीवी हो गया, जियो का
Charger, laptop.
लैपटॉप टीवी ओके चल लैपटॉप ओके फाइन so this is your what, this is your extension cord. Okay, the incoming current is considered to be as a positive, whereas positive I1, whereas the here TV source is also outward now. I've written it as an inward. Whereas all the currents which are going away, that considered to be as a what? Negative. Because they are taking out the current from the extension box, right? So these are what? Negative charges. But the sum of all the current together, if I will say sum of all current, that is I1 is coming to the set extension box, my plus minus of I2 to the TV, plus minus of I3 to the speaker, plus minus of I4 to the lights, plus minus of I5, it has been taken to the set-top box, plus minus of I6 is been taken by the laptop. The sum will always be the zero because the whatever the current is coming, the same current is taken out by the all the instruments. So net force will be what? Zero,
Yeah.
right? It means that whatever the incoming current, if I take all the negative this side, so negative will be equal to what? I1 is equals to I1 plus I2 plus I3 plus I4 plus I5 plus I6, right? So that is incoming is equal to outgoing. Understood?
Yeah.
Is for voltage also. Same phenomena, it will be for voltage also. Whatever, because we know wherever there is a current, there will be voltage, potential difference will be there. Because of the potential difference, only the current is moving, right? And wherever there is a current, there will be the magnetic field. There will be the force. Yes or no, Aditi? So this is the rule number 1. For sum of all the currents, the net current is become 0 because incoming is always equal to the outgoing. If, if, in a general case, in general, if incoming is greater than outgoing, what will happen? Incoming currents are coming too much, but outgoing is not so much. Then what will happen? Circuit causes fire because of the heat, and heat is creating because of the friction of the electrons when they are moving. So it catches, short circuit happens, correct? Similarly,
Yes.
if incoming is less and outgoing is more, then what happened? Switch trips. If in our house also incoming current is low and we have used so much of loads, we have switch on the geyser, we have switch on the chimney, we have switch on the washing machine, everything on that same circuit. Okay, because in our house is also divided into parallel series and parallel circuits. So in
Yeah.
that series circuit, if it with that switch, which is in our mains that we have already discussed it, right? Right?
Yeah.
So in that means if in the series circuit is connected with geyser, washing machine, oven, and some fan. Okay, two, three fan and two, three lights. So if all the instruments are coming out, so incoming current is low, but the outgoing is what? Geyser also takes so much of voltage.
Yeah.
Oven also takes so much of voltage. Correct? Fan doesn't take so much of voltage, fan and light, but these two are what? Over voltage, and that much current is not coming. Then what happened? Switch trips, correct? Short circuit happen. In this short circuit, circuit call catches fire, right?
Yeah.
But in this short circuit, switch trips and the power is cut off. Switch trips, power cut off. Here are the power cut off, but if it is desert, then it catches fire. The last ultimatum is what? It catches fire. Okay. Nowadays, switch always trips. But if switch doesn't trip, then obviously it will catch fire. Correct? So this is about the sum of the current. Same thing is for the voltage. If the this is the extension, here we have taken the voltage V1. This is V2, minus of V2, V1 is positive, minus of V3, minus of V4, minus of V5, minus of V6. So plus V1 plus minus of V2 plus minus of V3 plus minus of V4 plus minus of V5 plus minus of V6 is equals to 0. So this can also be written as V1 is equals to V2 plus V3 plus V4 plus V5 plus V6. That is incoming voltage is equal to outgoing voltage. Clear? So
Yeah.
this is the rule number 1 of the Kirchhoff's law. Vision Vichar?
Yeah.
Very good. Now look, now rule number 2. In rule number 2, this is also a circuit law. This one, what you said? Circuit law in which here in this circuit loop we always use what there are so many switches, sorry, so many batteries are there, so many resistors are there. Previously in series and parallel we are having one battery and so many resistors, right?
Yeah.
Correct. But here we are having more than one battery is connected, just like in your um, Uh, suppose if in the Diwali time we are using 2 or 3 extension boards, and so that we can lighten the whole our flat, right? To increase the wire length, we are using the extension board,
Yeah.
correct? So that the wire can reach up till there. So 2, 3 extension boards means what? 2, 3 supplies are there, right?
Yeah.
Correct. If we are just remove the extension board, in place of that, we are using here batteries. So in the circuit, if there are two, three batteries are there, there are in the just like in Diwali, we are using mini bulbs. Here we are using what resistors. There are multiple resistors are there. That time we are applying what Kirchhoff's law. Okay, so first rule we have studied. Second rule. Second rule is important. If you understand this rule, then you can solve any of the question from Kirchhoff's law. Now, the positive and negative terminal of the battery. The positive terminal of the battery is considered to be as a high voltage, whereas the negative terminal of the battery. Smaller is what? Negative. And this is a bigger one is considered to be as a positive. The negative
Yeah.
terminal of the body of the battery is known as what? Low voltage. Clear?
Yeah.
Okay. So if the current is moving like this, current is moving like this, but we
Mhm.
are traveling like this in the opposite direction. We are traveling. Okay. Within the loop, we are traveling in this way. Then from high to low voltage, I have traveled, correct? I have traveled from high to
Mhm.
low voltage. That time, the potential will be what? Negative V. Clear?
Yeah.
Now, mwah. Hmm. Now, if we suppose we are, this is your this way, we are going positive sign from the positive, the current is flowing now. Okay,
Mhm.
this is high and this is low. We are going from low to high. That time the voltage will be what? Positive.
But doesn't current only flow like in one direction, like from
Current for
negative
the
to
current,
positive?
it will be different. Current is flowing in
Mm.
the same direction. Current is always flowing from the positive terminal. It is not moving the negative terminal. Current is flowing in the positive
Yeah.
terminal, right? I
Yeah.
am going. I am going. I am going from high to low. Then that time it is negative potential because we are going against the
Mhm.
potential. Understand the
Mhm.
concept, na? Potential, the current is flowing where? From positive to negative. But we are going from the positive to negative. Sorry, positive to negative. Huh? So it will be a what? Against the potential. We are moving against the potential, right? So that's the result is what? Negative. And if we are going along with it, it is considered to be as a what? Positive. Okay. Now same thing is for current. Now suppose this is the register. Current is moving in this way. And we are going opposite to the direction of the current. This is your register having resistance R and current is flowing in the positive Y. Okay, current is going in this direction and we are moving in the opposite direction of the current. That time it will be what? Positive IR.
Mhm.
Clear?
Mhm.
Okay. Similarly, if the current is going in this direction and this is your register, this is your I, and we are also going against along with the current direction, that time the current will be negative IR. Okay.
Yeah.
Now third rule, rule 3. Sum of voltage and current register pair is always equal to 0. That is net will be always what? 0. Okay. Fine.
Mhm.
Because incoming voltage is becomes also 0. Incoming current in outgoing current will also become 0. Incoming voltage, outgoing voltage will also become 0. Right? So sum of
Mhm.
all the things will become what? 0.
So yeah.
Okay. Now let's do the numerical. Any doubt in this lecture?
No.
Very good. Now suppose if we are switching to the numerical part, question 1. Suppose if this is a circuit, instead of this, okay, this is your V1, V2, V3, R1, R2, R3. Okay, you have to find out the equivalent resistance. What is the output? Fine. For that, I'm just explaining it the overview how to do it. Suppose you have taken a note. Why? Wait a sec. This is your question. Have first always do what? After drawing the diagram, write the notes. Okay.
Mhm.
Hmm? After doing the notes, now step one. A, how you want to travel, clockwise or anti-clockwise? Aditi.
Clockwise.
Okay, clock is moving in this direction, right? From A, B, C, F, A. The loop should be closed, it should not be open,
Mhm.
right? In the
Yeah.
second step, step two, F, it's your wish, now. You will say, ma'am, why you are taking it from there? It's your wish, completely your wish.
In
I will blame you. D, E, F, C, D. But the thing is that the loop should be closed.
Mhm.
Okay. I am traveling in this direction. But the current is flowing in which direction? Current is flowing from high, right?
Yeah.
This is the direction of the current, correct?
Mhm.
Huh? So
Yeah.
now, if suppose if I'm taking this is as a I1, this is as a I2. So add this, this will be your I3. Okay? Three
Yeah.
batteries are there. So there will be three currents will be there. So here in AB, so we are going, current is going in this direction. We are going against the direction of the current. So obviously it
Yeah.
will become what? Positive I1, R1, right? We are going
Yeah.
from high to low. High to low means what? Negative V1, you can see above.
Mhm.
High to low is negative,
Yeah.
correct? Okay. Then Then after traveling to B, there any resistor? No. Then I travel to C to R2. So current is going in this direction. I am going against the direction of the current. So this will become
Mhm.
what? Positive I2 R2.
Yeah.
Understanding?
Mhm.
Current is going in this direction. I am traveling in this direction. Obviously, it is opposite. Now I am traveling now in this direction from high to low. From high to low is what?
It was
Negative.
negative.
See, na, the diagram is negative, na?
Yeah.
High to low. We are in the opposite direction, correct?
Mhm.
Correct. So minus of V2. And then after I'm traveling here, F, I have seen there is no register is there. So I have switched to A.
Mhm.
So the net force of all the pairs will be what? Zero.
Zero.
So what we conclude? I1 R1 plus I2 R2 minus V1 plus V2 is equals to 0. So I1 R1 plus I2 R2 is equals to V1 plus V2. Okay.
Yeah.
Now, similarly for question step 2, second part. I am traveling from D. Current is
Mhm.
flowing, I3 current is flowing in this direction. I am also
Direction.
going along with the direction of the current. So obviously it will
Yeah.
become what? Negative. I3, and this is
Wait, we
your,
are going in the other direction.
the direction of current is this one, na?
Yeah.
And I am also traveling from D to E. Acha, D to E. D to E.
Mm.
Sorry. D to E we are traveling. Yeah. We're not seen there. D to E. D to E. Okay, this side. So we are going against the direction of the current. So I3,
Mm.
R3. Then from
Yeah.
positive to negative, high to low. High to low is what? Negative of V3,
Negative V.
right? Then
Yeah.
F. F, there is no resistance. Then here, low to high. Low to high becomes what? Positive V2. Then we are going along with the direction of current. It means what?
Minus IR.
Minus I2 R2, correct?
Yeah.
Then we current is going in this direction. We are going against the direction of the current. It means positive I3 R4. And the sum, and then it becomes G at this point. So sum of all the things are become what? Zero.
No.
Okay, so this can be written as what? I3 R3 plus R4 minus II R2 is equals to uh, V3 minus V2. Correct?
Yeah.
Understood how to solve Kirchhoff's law?
Mm-hmm.
Easy peasy.
Yeah.